Welcome. Today, we journey to Mars, not the freezing desert we see now, but a world hinted at in the planet's rocks and dust. Our robotic explorers, NASA's Curiosity and Perseverance rovers, are our eyes and hands on the red planet, acting as remote scientists trying to understand its ancient climate and whether life ever gained a foothold there. The evidence they've sent back is compelling. Mars was once a watery world. Perseverance, exploring Jezero Crater, has given us a detailed look at what was likely a large lake fed by a river delta billions of years ago. Radar beneath the rover confirmed thick layers of water-deposited sediment, reinforcing Jezero as a top spot to search for preserved signs of ancient life. The rover found volcanic rocks that clearly interacted with water and later discovered abundant sulfate minerals within rock fractures, a telltale sign of water evaporation. Different types of these sulfates suggest water was present both near the surface and deeper underground over time. Not far away, geologically speaking, the Curiosity rover in Gale Crater had already found clear signs of ancient freshwater lakes and stream beds, including rounded pebbles smoothed by flowing water, in areas containing the chemical ingredients necessary for life. Even China's Zhurong rover may have detected radar evidence of buried structures consistent with an ancient coastline in Utopia Planitia. So how could Mars have stayed warm enough for liquid water? Scientists believe an early, thicker atmosphere rich in carbon dioxide was necessary. Recently, Curiosity provided strong support for this idea. While exploring Mount Sharp, it found deposits of an iron carbonate mineral called siderite. This is a huge discovery, the first direct evidence found on Mars of an ancient carbon cycle, where atmospheric CO2 dissolved in water and reacted with rocks. While perhaps not as thick an atmosphere as some models suggested, given carbonates aren't found everywhere, it shows CO2 was present and playing a role. But the climate wasn't stable. Curiosity's analysis also points to dramatic shifts, perhaps cycles of wet periods followed by intense drying, or times when minerals formed in very cold, salty water. It paints a picture of a planet transitioning from warmer and wetter conditions to the cold, dry Mars of today, largely due to its atmosphere being lost to space over billions of years. Some studies suggest other gases, like hydrogen released from geological activity, might have occasionally helped warm the planet too. All this evidence for water, essential chemical elements, and potential energy sources confirms that habitable environments absolutely existed on early Mars. This brings us to the ultimate question: was Mars actually inhabited? To find out, we look for organic molecules, the carbon-based building blocks of life. And incredibly, both Curiosity and Perseverance have found them preserved in ancient Martian rocks. Curiosity detected relatively complex organic molecules, including sulfur-containing ones, and others related to fatty acids, within 3 billion-year-old mudstones. Perseverance, using different instruments in Jezero Crater, has also detected various organic molecules, including aromatics, associated with minerals formed in water. Now, these molecules don't automatically mean life. They can form through geological processes too. But finding diverse types preserved near the surface, despite Mars' harsh radiation, is incredibly encouraging. It suggests that if definitive signs of life, or biosignatures, were created, they might also be preserved and detectable. Add to this the intriguing seasonal puffs of methane gas. Curiosity has measured. Methane can come from life or geology, and a recent intriguing rock analysis by Perseverance, potentially showing signs consistent with microbes, though non-biological causes are still being explored. The picture emerging from our rovers is one of a dynamic early Mars, far more complex and potentially habitable than we might have imagined. While the rovers continue their amazing work, the definitive hunt for evidence of past life really hinges on getting samples back to Earth. Perseverance has been busy collecting and caching core samples of the most interesting rocks it finds. These await a future Mars sample return mission, which will allow scientists here on Earth to use our most powerful instruments to finally seek undeniable proof of whether life ever existed on the red planet. Thanks for listening.